All right, guys. So we've talked about almost all the triangle congruence theorems. We've talked about, let me flip open, side, angle, side. We've talked about side, side, side. We've talked about angle, side, angle. We've talked about angle, angle, side. There is one more. Now, we've talked in class about a special one that we don't have, and that's angle, side, side. And we're going to talk about why that one doesn't work. I'm going to show you a quick video that I think is funny. You will be like, wow, you really think that's funny? Like, is there something wrong with you? But anyway, to show you why angle, side, side doesn't work. And then we'll talk about a special case in which it does, but we call it something else. So we're going to watch this quick video to show why it doesn't work. It won't let me press play.
So now that we've covered the 5 triangle congruence theorem, you may be asking, what about angle side side? Please don't be uptight. Okay, so now let's go ahead and explore why angle side side would not work as a triangle congruence theorem. So if we have a set of corresponding angles that are congruent and a set of corresponding sides that are congruent. Okay, so we have 2 sets. We have an angle followed by 2 consecutive congruent sides. The issue is with that second congruent side, since we don't know the angle in between the 2 congruent sides, we don't exactly know its position. So I could take that side and swing it over to a new location and still show that angle side side is still the case here, no matter how I choose to draw that second triangle. And I have the option of drawing it either way, since that's an isosceles triangle, so both of those sides are definitely congruent to each other. Now, if I draw it this way as an acute triangle, I see that I have angle side side. However, the base of each triangle clearly are not the same, and these triangles clearly are not congruent. So, due to this ambiguity, angle side side or side side angle is not enough to prove that 2 triangles are congruent. Thanks again for joining us, guys. I hope you had some fun on this one. Remember, math can be fun, so don't be afraid to laugh. See you next time.
All right.
Thanks a lot, guys, for checking us out, and please follow us on Instagram at MashUpMath for daily math tips.
All right, so that one doesn't work. However, there is a special one that will work. What he showed will work and will only work if you have a right triangle. So instead of calling it ASS or SSA, we call it hypotenuse leg. Don't go around calling people a hypotenuse leg. They won't get it, okay? In this situation, we have a hypotenuse across the right angle and a leg. We have to have a right triangle. So even though it says HL and you're thinking, well, I have to have 2 things, you have to say it's a right triangle for this to work to begin with. So we're going to talk about hypotenuse leg. This is the last triangle congruence theorem. Now, another one you might be saying, well, this one's missing as well, is angle, angle, angle. That one also doesn't work. There are videos about why that one doesn't work as well. It's possible to have different side lengths in a triangle with angle, angle, angle. All right, 6.3 HL Triangle Congruence. It's on page 56. So 6.3 HL Triangle Congruence. We're going to take pages out of your book. Okay, we need to tear out page 296 and 297.
Teachers, if you ordered a drink, or anyone, if you ordered a drink from Manchester Nutrition, please come to the main office to get those.
Well, there's your nice interruption, but oh well. All right, 296 and 297. From 296, you're going to cut out the theorem. You're going to go back and write it in later. Let's go ahead and glue this, page 56. That's the only thing we need from this page. Not on this page, but from page 296. Okay, and then from page 297. You need example A. That's not all you need from that page, so don't get rid of it yet. Example A, while this is drying down here, I'll show you what goes on page 57 from this page. And from the rest of that page, you're just going to cut the rest of it out, stick it on page 57. So we can talk about our last triangle congruence theorem. Yeah. Okay, so let's go ahead and work these. We are just proving today. Example 2. Example 2 says, use the hypotenuse leg congruence theorem to prove that the triangles are congruent. So in hypotenuse leg, we have to say that they're right angles. We don't have to say they're congruent, just that they're right angles, which means it's a right triangle. We have to say that we have legs congruent and that we have a hypotenuse congruent. Now, it does not matter which leg is congruent. All that matters is that we have some. So we're going to start with statements, of course, and then reasons, and then we will prove from there. Just because something is a right triangle does not mean you use hypotenuse leg. It can still be side, angle, side. It can still be angle, angle, side. It can still be angle, side, angle. It is only hypotenuse leg if you have a right angle and two sides, okay? And that two sides are like a leg and a hypotenuse. If it's two legs and this angle, that's side, angle, side. So just because it's a right triangle does not mean that it has to be hypotenuse leg. All right, so we have two givens. Drop my pen. Our first given is that angle P and angle R are right angles. We're going to use our symbol for right angle. And that's given, and it's already marked in our figure. Our second statement is that PS is congruent to RQ. And that is given. Okay, so we already have quite a few things. We've got to prove the triangles are congruent, but we already have PS and RQ. That's a leg. We already have right angles, so therefore the hypotenuse leg will work because we have right angles. We need the hypotenuse. The hypotenuse is across from the right angle, so it is SQ or QS. Well, guess what? Those are congruent because it's the same line. So number 3, SQ, we have to see if we need to swap it or not. S is on the side with the one mark there, S to Q. Well, Q is on the side with one mark, so we do have to reverse it, QS. Also, in case you're ever wondering if I have to reverse it or not, you can look at the triangle, QS, SQ, so I did have to reverse it. And that is by the reflexive property. Okay, I have hypotenuse, a leg, a right triangle, a right angle. So triangle PQS is congruent to triangle RSQ by hypotenuse leg congruence theorem. There we go. Let's look at letter B. Given that J and L are right angles, that's given, it's also marked, and K is the midpoint, given. We are to prove that JKN is congruent to LKM. Number 3. Sometimes instead of using, because we could have used 5 lines here, and you probably would have, sometimes they'll put more than one thing in here if the reason is the same. I couldn't get it together there. If the reason is the same. You don't have to. You probably would have done 3, 4, and then 5. Which is why if they have blanks in your book, you might not use them all, and you might use too many, okay? It's fine. The blanks in your book do not mean that's how many steps you have to have, okay? All right, so number 3. Since we know that K is the midpoint of both JL and MN, we know that JK is congruent to LK. That is the definition of a midpoint. Okay, also, MK is congruent to NK for the same reason. Now, I have a right angle and I have 2 sides. The sides specifically are a leg and the hypotenuse. So JKN is congruent to LKM by the hypotenuse leg triangle congruence theorem. I left off the triangle part on this one, on letter A. Go back and put that little symbol. All right, number 4. Is it possible to write the proof of B without using the hypotenuse leg congruence theorem? Explain. I want you to pause the video, take a minute, and see if you can answer that question. Is it possible? Okay. The answer is yes. And I'm using a different color because I don't want you to, this wasn't part of the proof. We're just going to go back and label this diagram. We could have said that angle JKN is congruent, JKN is congruent to LKM because they are vertical angles. That then gives us side, angle, side. So that, which lets us use side, angle, side, triangle, congruence theorem. So that goes back to, it takes me a little longer, or will, to grade something with a proof because there are different paths to prove things. It doesn't have to be the same as how I've done it here. It doesn't have to be the same as how somebody sitting next to you in class does it, okay? So that's what we could have done. You don't have to have all of that written. If you have another explanation, that's fine. Now, the only other one we could have used was side, angle, side. We didn't have enough information to do side, side, side or something. All right, I want you to pause the video and prove number 5. So you paused it, but I'm starting it anyway. Statements. Reasons. Okay. I gotta move this up. Okay, I have a couple of things. I have angle CAB and D, B, A are right angles. Is that labeled? Yes. I have AD is congruent to BC. That's given, but not labeled. This is one of those that I almost would rather draw it separate so you can see what's going on. AD is this whole length right here. It's hard for me to mark that, but it's this whole thing, okay? BC is the whole thing, not just this portion, but the entire piece. Since the right angle is here, BC and AD are the hypotenuse, okay? So that means all I have to find is a leg. The leg options I have are AC and BD or AB and AB. Well, I know AB because it's the same segment. I'll have to figure out if I have to swap it or not. AB is congruent to, A is the right angle going to B. Well, then in this triangle, so in this triangle, A is the right angle. But in this one, B is the right angle. So I do have to swap. Again, if that confuses you, if you look at this statement here, they're swapped in that statement. So number 3 is by the reflexive property. Okay, now I have a right angle, 2 of them. I have side, no, that's the hypotenuse. I have the hypotenuse, I have a leg. So triangle ABC is congruent to triangle BAD. The hypotenuse leg, triangle, congruence theorem. Okay. Go ahead and start on your assignment for today. I'll see you later. If you are a distance learner, there will be a Google Meet tomorrow instead of a video, so make sure you log on.